This conference will now be recorded.
Right, let's start today's session. In the last session of Python, we were discuss about inheritance concept. We have seen single inheritance and multi-level inheritance. And today we'll look into other types of inheritance like hierarchical, multiple, hybrid, and also we'll discuss constructor role in inheritance process. First, we'll see hierarchical inheritance. So hierarchical inheritance means creating new class from creating multiple child classes from single parent. This is hierarchical. So let me draw the diagram of hierarchical inheritance. Let's go to paint. Here I'm drawing. This is hierarchical. One parent class, two child classes. Two childs are inherited from single parent only. This is hierarchical inheritance. In the last session, we have seen single inheritance and multi-level inheritance. Single inheritance means creating new class from single base class. Multi-level inheritance means creating new class from already derived class. It's called multi-level inheritance. Hierarchical inheritance means creating multiple child class from single parent class. For example, here you can see this is parent class, and now you can see child 1, child 2. These are child 1, child 2 classes. Child 1, child 2 are inherited from same parent only. In this context, we should create object for child 1 as well as child 2 also. Let's try to create one simple program, and also I'll try to introduce some more functions which is related to inheritance only. So object-oriented programming 18. So let's create a class called parent. In this parent, I'm creating function f1 print parent class function. Okay, f1 function of parent class. F1 function of parent class, we can say that. So let's create one more class like child1 class child1 which is inherited from parent. So df f2 is there, print f2 function of child1. Next, let's create one more class child2 which is inherited from parent again. df f3 print f3 function of child2. F3 function of child2. Okay, this is. So look at here, this is hierarchical inheritance. Child1 and child2 are inherited from same parent only. That means child1 and child2 classes are going to get the functionality of parent. But in this hierarchical inheritance, we should create object for child1 as well as child2. Sir. So C1 is my object of child1 class. C1 through we can access F1 function, that is parent class function. C1 through we can access F2 function, that is child1 function. C2 equals to child2. C2 through we can access F1 function because it's a parent. C2 through we can call F3 function, it's a C3 F3 function, F3 function which is related to C child2 only. Once I begin this execution, now we can see we got this output. F1 function of parent class, F2 function of child1. F1 function of parent class, F3 function of child2. So both child classes can have right to access parent class function, that is called F1 only. We created object for child1 and child2. You must create because every child can able to get the logic of its parent only. Parent is common for both childs only. How many number of childs are inherited from parent? That many objects we have to create it for child classes only. So in this hierarchical inheritance context, I am going to introduce some functions, built-in functions. So is instance function is there, is subclass function also there. These two functions I'm going to discuss. What is instance and what is subclass function? These two are inheritance functions only. Let me discuss these two functions. So is instance as well as is subclass. First one I'm taking is instance. This function is used to check. This function is used to check whether the object is an instance of particular class or not. Particular class or not. Is instance function is used to check whether the object is an instance of particular class or not. It will check. Second one is subclass is there. Is subclass function. Is subclass function is used to check whether a class is a subclass of particular class or not. It will check whether the class is a subclass of particular class or not. It will check. So what is the use of is instance method? Is instance method is used to check whether the object is instance of particular class or not. Is subclass method is used to check whether the class is a subclass of particular class or not. It will check. So let's try to implement or try to show you example here. So to show the examples, let's try to delete this. I don't want to call this functionality. Only I have to include C1 and C2 object. You know very well C1 is child 1. C2 is object of child 2. Now I'm trying to apply is instance method first. Is instance. C1 is an instance of child 1. Is this correct? Yes, obviously. So C1 is an instance of child 1. So it return true, sir. True or false only it return. Is instance method, is subclass method will return true or false only. So is instance of C1 comma child 1. So true, sir, it is. Because C1 is an instance of child 1 only. But if I try to say C1 comma child 2, is this C1 object is an instance of child 2? No, undoubtedly no. So in this context, it return false. So C1 is an object of child 1, but you are asking C1 is related to child 2, but actually C1 is not related to child 2. C2 is object of child 2. Yes, C2 is an instance of child 2 only. This is true. C2 means object reference of child 2. It's correct only, sir. So true only. But let me show you. C1 is instance of parent. Yes, exactly. Because child 1, child 2 classes are inherited from parent only. But indirectly, C1 is also an instance of parent only. C1 is an instance of parent. Correct. C2 also instance of parent. Correct. So this method, is instance method is look like. Is instance method with whether the object is an instance of particular class or not, you can check this by using is instance method. So next I'm talking about is subclass method. Is subclass method is used to check whether the class is subclass of particular class or not. Let me show you. I'm using is subclass method. This is subclass method child 1 is the subclass of child 2. No, sir, it's not correct because child 1, child 2 both are subclasses. But you are checking what child 1 is a subclass of child 2 only. That's not correct. Child 1 is not subclass of child 2. Look at your false. Child 1 is subclass of what? Parent. Child 1 is subclass of what? Parent only. Now is it true only. This child 1 is subclass of parent class. Correct. Child 2 also subclass of what? Parent. Correct. So this is the way to check which class is subclass of which parent class, whether the class is subclass of parent class or not, or whether the object is an instance of particular class or not. We can check by using this methods. What methods? These are instance method. Sorry, inheritance method. These instance method, is subclass methods are available here. These two are methods which are related to inheritance. So next I'm talking about multiple inheritance. Single, multi-level, hierarchical. Next I'm trying to discuss about multiple inheritance. What is multiple inheritance? So multiple inheritance is the process of multiple inheritance. Multiple inheritance is the process of creating new class, creating new class from two or more base classes, two or more base classes. Multiple inheritance is the process of creating new class from two or more base classes. Okay. So in C#.NET or in Java programming language, multiple inheritance is not possible without having interface concept. That's the reason C#.NET programmers, even Java programmers use interface concept. But when it comes to Python object-oriented programming, multiple inheritance is easily possible because multiple inheritance implemented in Python using a technique that is called MRO technique. MRO means method resolution order. Suppose this is first class, this is another class, that is class B, and here it is class C. So multiple inheritance example is this one only, creating new class from two or more base classes. At base level, two classes I'm including here. I'm taking this class A, class A, class B, class B, then class C here I'm taking, class C. So C class is inherited from A and B, sir. Okay. So this is multiple inheritance, but this inheritance is implemented using what technique? MRO technique. It's an algorithm actually. Method resolution order. M for method, R for resolution, or for order, resolution order. MRO, method resolution order. So this order is always clockwise, means so when we create object for child class like C, when we try to access parent class function, first priority will give to A class, that is parent class only. Relevant method is not available in A class, then immediately next priority goes to what actually? B class only. So this priority is always what actually? Clockwise only. It's not about anti-clockwise. Order is look like only. So here A and B are parent classes. C is the child class. Obviously, we have to create object for what actually? C class only. In through C class object, we are trying to access A and B functionalities. But some of the functionalities not possible, not available in the class A, the next priority it will go to B only. So this is the MRO technique, method resolution order through we are doing. Now let's try to implement the logic. So here I'm creating one more class, that is object-oriented programming 19. Object-oriented programming 19. Let's implement A class. F1 function is there. Inside this, I'm just calling F1 function of class A. I'm creating one more class, that is B. Df F2 function I'm taking inside the B. Let's go for F2. function of class C, class B. So two are parent classes, base level A, B classes. Let's try to create a C class. It is inherited from A and B. This is multiple inheritance. Now we can see A and B classes are giving features to C only. That's what arrow mark is coming down, up to down. So these features are coming to child classes. So in this C class, we have F3 function, print F3 function of class C. So now we should create object for C class. Small c is a object name, capital C is a class name. Using small c, we can call function of F1 like it is coming from A. So we create object for child class. Once we create object for child class will get the details of parent class A and B only. So C dot F1 is possible. And C dot F2 is possible. Yes, it is coming from B. C dot F3 is possible. Obviously, it is coming from C class only. So all the functionalities we are able to access. Let's execute object-oriented programming 19.py. So we got F1 function of class A, F2 function of class B, F3 function of class C. So it's clearly implementing multiple inheritance. So at base level, two classes are there. Each class is having a function called F1 and F2. So C class function, C class object through, we are trying to access F1, F2, F3. So F1 is coming from A, F2 is coming from B, F3 is coming from C. This is very clear, sir. But observe carefully. Whenever I'm trying to take inside the class B also same function I'm taking F1 and F1. This is the point, sir. Both classes are there. F1 function of A, F1 function of B. Now F2 is not there, F3 is there. Okay, no problem. But in this context, when we try to create object for C class, when we try to access parent class function F1, which class F1 function will come? Observe here. There is no F2, I'm deleting. But look at here, C dot F1 I'm taking, F1. So F1 is coming from where? A. Why? Because the priority goes to first A only. So obviously A class F1 function is coming, sir. Just observe it, C dot F1 means A class F1 function is coming. So order is method resolution order is what? First A, then after B. But A is having function, no F1. So B will not work out. Because in case A is not there, then B class F1 function will give priority. But A class is having F1 function. That's what B is not coming. Suppose you can see I'm trying to take this comment section. Comment it. Comment means there is no body of the class A. But if you don't have body of the class in class A, then you have to use pass keyword compulsory. Without body of the class, it will not allow. If you are leaving any class inside, there is no body of the class, then you can make the pass only. Right now, there is no F1 function inside the class A, but we are trying to create object for C. C through we are calling F1 function. First, it look forward F1 of C A only, but there is no F1 function of A, so it's going to be B only. Look at here, the priority goes to B. Let's run this. F1 function of class B is coming, F3 function of class C is coming like this. This is the priority. Sir, both can't we get F1 of A and F1 of B? Yes, we can get. No problem at all. I'll try to show you. But don't think so. The order is look like. Suppose here you can see this. B comma A I'm taking. First order is what actually? Now you can see. I'm including this one. Now you can see. So B comma A I'm taking. Because of this B comma A only, first priority goes to B, sir. F1 function of B only, you can see. It's not because of diagram A comma B. Don't think so by looking diagram it is anti-clockwise. No, we are changing this only. Just what? In place of A, we are changing what? B. In place of A, B, we are changing what? A only. So order is perfect. First order is what? B only. Then next order is what? Actually A, like this. Order is perfect. Got my point? Yes. So B comma A means first B, first priority C class, C dot F1 of B only. In case B class don't have F1 function, then priority goes to next what? A only. Suppose let's comment this one. B class F1 function I'm commenting. So inside the B class body, I'm using pass. So first it look forward for B class F1 function, but there is no F1 function of B. Immediately priority goes to next only A. So C dot F1. So F1 function of A, F1, F3 function of C. So this is the logic, sir. If the base classes like A and B are having same function like F1, but first according to multiple inheritance rule, method resolution rule, so only first class function will call. But obviously we will miss second class function. For example, A comma B means A class F1 function only will come. B is missing here. But I'm saying can't we get the B class F1 function also? We can get. But how we can get? Through derived class function. Derived class means C class is derived from A and B. Inside the F3 function, which function of class we are missing? B class F1 function of cell. Now this time we'll get B class F1 function also through F3 function. So though in the base class, both classes are having same function, still we can able to access that same function from A and from B, but one of the function we can access through derived class function only, that is F3 inside B dot F1 I'm saying. So this is multiple inheritance. We can create multiple inheritance easily in Python because there is method resolution order is there. But actually this concept is not possible in Java as well as C#.NET, sir. The reason is there was an ambiguity situation will rise. Ambiguity situation means confusion state. If in Java point of view, in C#.NET point of view, if base classes are having same method, then that is going to become ambiguity, confusion state. But in Python, there is no ambiguity situation because multiple inheritance implemented using method resolution order only. So this is multiple inheritance. Next, let's go for hybrid inheritance. See, hybrid inheritance is the combination of multiple, multi-level, hierarchical. Let's try to go for hybrid inheritance example. This is actually right now hierarchical, multiple inheritance. Now let me go for here. This is what actually hierarchical inheritance. This is the combination, sir. So what is this? Hierarchical inheritance. Creating multiple child from single parent class. So I'm taking here class D, class E only. So this is hybrid inheritance. So A, B are base level classes, C. So when we look this, A, B, C are multiple. This is only multiple, sir. This is multiple. Next, C, D, E is what? Hierarchical. So this is hierarchical because creating multiple child classes from single parent and creating new class from two or more base classes. First one is multi-level, sorry, multiple. Second one is hybrid. Second one is hierarchical. But A, C, D, what actually? Multi-level. Or B, C, D, B, C, E. B, C, E is multi-level. A, C, D is multi-level. This is multi-level, sir. This multi-level. This is also multi-level. Okay, like so. Multi-level is there. Multiple is there. Hierarchical is there. All are there. But except single. Single is not included, sir, in the inheritance of hybrid. Let's see practically. We'll extend the logic here. Okay. What logic I'm extending? I need to create object for what actually? D. D is inherited from C. So D class is having F4 function, print F4 function of class D. Again, C class also should inherited from where? Sorry, E class also should inherited from where? C only. Df F5 function, print F5 function of class E. Now tell me, we should create object for which classes? Then only you will get all the details. We should create object for which classes? Then only we will get all the functionalities of entire the classes. Look at this diagram and tell me, which class object should I create? D class object you should create, and also E class object you should create. Okay, that is for sure, because two child classes object must and should create. D equals to D, E equals to E. So D dot F1 is possible, D dot F3 is possible, D dot F4 is possible. F4 is belongs to D only. Even E dot F1 is possible, E is eligible to access parent. E dot F3 is possible, E dot F5 is possible, F5 is possible, F4 not, F4 is belongs to D only. So this is what actually hybrid inheritance one scenario. Here I have included what actually multiple, multi-level, hierarchical. Excuse me. And other way also it is possible, sir, multiple inheritance. That is diamond shape mechanism, we can call it as. So what is diamond shape mechanism? We'll see. Let's see this other way also. See, this is base level 1 class. This is hierarchical first. Hierarchical is possible. And next multiple is later. This is diamond shape scenario. So look at here. These two classes are inherited from single base class. This is called hierarchical. We are creating new class from two base classes. This is called multiple. So here I'm taking class A. Here I'm taking class B, and also class C, class D, class D. So this is what again hybrid inheritance we can say. So A, B, D, multi-level, A, C, D, multi-level, A, B, C, hierarchical, B, C, D, multiple. So always hybrid is the combination of multiple, hierarchical, multi-level. This scenario is called diamond shape scenario. In C#, .NET, Java, it is not possible, sir, because that's what they will call it as diamond shape problem. But there is no problem with diamond shape here because of in Python, everything is possible, all the inheritances. Let's quickly do this example. First, I have to create A class. So let's remove this A class. Now you can see B and C are inherited from A only. B is inherited from A, and B class is having F2 function. C is inherited from what? A. C class is having F3 function. Let's try to do this. So here you can see B is inherited from A, C also inherited from A only. Okay, here df F3 function I'm taking. Next, C class, B and C classes, we are taking D only. D is inherited from B and C. Class D inherited from where? B comma C only. This is also hybrid inheritance. df F4 function, print F4 function of class D only. We should create object for what's our D class. D class through we can call F1, we can call F2, we can call F3, we can call F4. Everything is possible. So this is also multiple inheritance. F1 function of class A, F2 function of class B, F3 function of class C, F4 function of class D, sir. So hybrid, multiple, multi-level. So multiple, multi-level, hierarchical is the combination is called hybrid only. So these are all inheritance related examples. But still we need to discuss constructor role in inheritance also. We included in the all inheritance concept methods only, but how we can work with constructors. Constructor role in single inheritance, multiple inheritance, multi-level inheritance we have to discuss. Let's quickly discuss the constructor role also. Object-oriented programming 20. Let's create a class A. Inside this class A, I'm taking constructor. So here this is A class constructor, we can say that. A class constructor. I'm taking class B. Inside the class B also we have constructor. B class constructor. I'm trying to create object of B only. So when we create object to the class, you know that constructor automatically executes B equals to B. So which class constructor executed? B class. That is true. In case if there is no constructor present in B class. Okay, there is no constructor present in B class. So what will happen in this case? We are pointing to B class only while creating object, but B class is having constructor, but no output because B's don't have any constructor. But look at here. If B is inherited from A, if the B class is having constructor, B class constructor will execute. In this case, B is related to A class. So if you don't have any constructor in B, immediately according to MRO rule, MRO technique, method resolution order, the priority goes to what? A class only. So this is the constructor role in single inheritance. In case if we have constructor in B, so first B class constructor only will execute, sir. If the B class constructor is not there, then priority goes to A only because it is inherited from A only. Similarly, we have to use multi-level also. C is inherited from B now. This is what actually C class constructor is there. C class constructor. When we try to create object for C class, C equals to C only. So obviously C class constructor will be priority. If there is no constructor in C class, then next priority what, sir? B. If there is no constructor in B class, next priority what, sir? A. So this is. So priority is changing, sir. Okay. This is constructor role in multi-level inheritance. I'm doing Control Z back. Now this time you can see A, B are parent classes and C is inherited from AB only. This is multiple inheritance. We created object for C class, so C class constructor only priorities. If there is no constructor in C class, then first priority according to MRO rule A, because order we mention A comma B only. Once I run this, A class constructor is executing, B is not executing because order is there. So in this order, if there is no constructor in A class, then priority goes to B sir now. Okay, this is the order is important. Suppose first B comma A I'm taking. The order is fixed, B comma A. First priority what? B class constructor. Yes, B class constructor is there. If there is no constructor in B class, next priority what, sir? A only. So A class is having constructor. So it will go to A. First actually it will go C class because we created object for C only. If there is no constructor in C, then immediately priority will be changed, sir. See here, constructor is there in C. C only will execute. There is no B and A. So this is about constructor role in single inheritance, multiple inheritance, hierarchical common, high level, multi-level hybrid also common. So this is overall inheritance in Python programming. So we discussed in the last session encapsulation, and we discuss here inheritance, rules and regulations, including multiple inheritance. Next, we have to discuss about polymorphism. Polymorphism means what I said. Poly means many and morph means behavior. In Python programming, if we take any function or operator, it will show different behavior when we change the purpose of the operator or when we change the arguments of function or parameters of the function. So automatically, what we can say, behavior will be changed. If the function behavior is changing, depends on situation, that is called polymorphism nature. Polymorphism can be of two types in Python programming. One is static polymorphism. It also called as compile time. Next one is dynamic polymorphism. It also called as runtime. Overloading concept is related to static polymorphism. Overriding concept is related to dynamic polymorphism. Overloading means every time we should keep on changing the code at the time of writing the code only, not at the time of running the code. That is what we can say overloading is a refinement technique. Overriding means you should keep on uh, replace the code. Means during the runtime only, the code gets replaced with existing functionality. So that is replacement technique. So ultimately what I'm saying, overloading is the concept of polymorphism like static. Overriding is the concept of dynamic polymorphism. Overloading is a replacement technique. Overriding is a replacement technique. Overloading is a refinement technique. So there are different types of overloadings are there. What are that? Operator overloading, method overloading, constructor overloading. So which is going to support and which is not, we'll discuss. Now coming to this overloading. Overloading are three types. First one is operator overloading. Next one is